So our next compounds that we're going to take a look at to name and draw today are cyclic hydrocarbons and compounds that are considered aromatic, and we'll talk about why they are. And there are a few diploma questions that we can go over in this as well. So the first part is just talking about what a cyclic hydrocarbon is. So just included the slide just to say that it is going to be a ring essentially. So there's no beginning, no end, but in terms of what we know, we're still following our rules of naming up until this point. And we can have alkanes, so single bonds, alkenes, so double bonds, or alkynes when we are looking at it. And they do have similar formulas as their straight chain counterparts if we were going to use that formula. Now, looking at drawing them and knowing if it's cyclic, the biggest difference here is it has the word cyclo. If you see the cyclo or the prefix cyclo, it just means you're going to connect your points. So propane, we know, involves 3 carbons. Again, I'll do line diagrams just because they're faster. And so propane, if you have 3 carbons, we're just going to connect 3 points. So understanding that would mean there's a carbon right here, a carbon here, and a carbon here. And then anything that's not bonded to carbon is bonded to hydrogen. So each of those carbons would still have 2 hydrogens. Cyclohexane. So cyclo means a ring, hexane means 6. So if we draw that out, we have 1, 2, 3, 4, 5, 6. So we have all of them connected, and then ending in ane, we know it's just single bonds. The next one, 3-methyl cyclohexene. So ene meaning there's a double bond, cyclo meaning it's going to be connected. So we're going to start the same way by drawing out as if it was just single bonds. Then you could put the double bond wherever you want. So on our diagram, just between 2 carbons, you're just going to add another line. And now in terms of numbering, we don't have to say where the double bond is because it's always going to be between carbon 1 and 2. So wherever you put that double bond, you now have labeled carbon 1 and 2. And if that is my carbon 1 and 2, then on carbon 3, I need a straight line showing that there is a methyl group there. So now I've accounted for it all. Moving on to letter D, we have 1-ethyl, 3-methyl. But more importantly, cyclo, making it a ring, and pentane, telling us how many we'll have. So pentane, we're going to draw 5 carbons in a chain connected. Then it ends in ane, so we know it's all single bonds. Then if you have 1-ethyl, 3-methyl, again, with your rings, it won't matter where you start. And because we don't have a double or a triple bond, there are no specific 1 and 2 carbons. But what we will do is just pick one. So I'm going to say this is carbon 1. And whether I go clockwise or counterclockwise, I just have to make sure my methyl group is on the 3rd carbon. So whichever way I go. So if I have 1-ethyl, ethyl would look like this, right? You have 2 carbon chain and with all your hydrogens, and 3-methyl gives us 1. I think I'm going to skip this one for now just because decane is a little harder to draw, and I like that space, but it's still the same idea. You would draw 10 carbons in a circle. Anywhere you want, you would put that double bond, and then you would add on carbon 5 an ethyl group, and on carbon 3 and 4 methyl groups. So here's an old diploma question bringing in cyclo. So first off, we can take out the distractors because they don't have cyclo in the name. And now when we're looking at our structure, like up at our compound up here, and we're going to name it. So it says we need to figure out what's on carbon 1 and then what's the rest. So when we're looking at this, we know that your ring has 4 carbons. So 4 carbons is butane. So we're looking for cyclobutane, which both of these are showing. And then when it comes to your side groups, this group is a methyl group. And this group there's 3 carbons. So this is a propyl group. Now, when it comes to naming your side groups, it's still alphabetical. So if you sing your alphabet, LMNOP, methyl comes before propyl. So methyl needs to be named first. So here your answer would be B. Now, the next part, when it is cyclic, a common compound you'll see is benzene. And benzene, in the more recent diagrams, you'll see it drawn like the compound on the right. But what it is an alternation of those double bonds, and you can draw those in two different ways. So notice your first way, and then you have the double bonds being in the other direction on the second way. So that's your resonance structure, where they're not exactly the same, but essentially they are still very similar. But the theory before was that your double bonds would switch between carbons. So you would have one of these always present. But now, and with more education, we know that it's actually being shared. So instead of having alternating double bonds, instead they just draw the circle, meaning that every bond within the example or within the compound, they're sharing those electrons. So it's not just single, it's not just double, it's a bit of a mixture of both. So when you are recognizing that you have a benzene ring, you want to be able to name it based on that, and it would just be benzene. But if your chain that benzene is attached to is greater than 6, then it's no longer the main group, and it is now a branched group. And instead of calling it a benzene ring on it, you call it a phenyl group. So you act like a phenyl group, like a methyl or an ethyl group. It's just on your main branch. So for instance, if I was to name this compound that I'm seeing in front of me, I would start on the right, just because that would give my benzene ring on carbon 3, which would be my lowest carbon possible, right? Because we still want the lowest side group. Lowest number for the side group. So when we're looking at this one, there's 7 carbons and there's no double bonds, means it's going to be, I'll come up here, heptane. And then on carbon 3, you have that benzene ring, and it's going to be a phenyl group. So this would be 3-phenylheptane. Just drawing a few more with benzene. So if you had 2,3-diphenyl nonane, nonane means you have 9 carbons in your longest chain. So doing a line diagram, starting at 1, 2, 3, 4, 5, 6, 7, 8, 9. And on carbon 2 and 3, you have that phenyl group, which is benzene. And the di word just means you have 2, which makes sense because we're seeing it in 2 places. So we'll put a benzene group here. Let's act like that looks better. And so that's carbon 2. And on carbon 3, same idea. We want that benzene. Now, with that second example, which should be labeled B, 2-ethyl 1,4-dimethyl benzene. So now benzene is your main group. It's not going to be a branched group. So we'll draw that, your benzene ring, and then you just need to pick. So we have those alternating double bonds because they're alternating and they essentially are on every carbon. It doesn't matter which one you call 1 or 2 because there are many. So we're just going to start by numbering somewhere. And then we'll start by adding those side groups. So now that it's numbered, then on carbon 2, I want my ethyl group. And on carbon 1 and on carbon 4, I want methyl groups, which is just that line going down. Now, here's another old diploma question. And it's a bit, or a lot older, you can tell by the formatting. But it just wants us to be able to draw out our compounds and see if it's named correctly and if it has the isomer C6H12. So we have that first one, and you have, which of the okay, and the name of an isomer. So here, looking at A, you do have 6 carbons, which we need, right? We have 1 here, 2, 3, 4, 5, 6. And then to count your hydrogens, there's 3 here. There'd be 1 here, 2, 2, 2, 2. So counting those all up, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one definitely works. And this would be methyl cyclopentane. So it looks like your answer is A, but let's make sure by ruling out the rest. So if you have cyclohexene, you know you have that double bond, which we see. We can number our carbons, 1, 2, 3, 4, 5, 6. So you still have 6 of them. And then looking at your hydrogens, up here you'd only have 1, over here you'd have 1, and on all the other ones you'd have 2. So 2, 4, 6, 8, 10. So this is not going to work because we need 12. Going down to C, going through the same thing. So we have 1, 2, 3, 4, 5, 6 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Not an option. And the last one we can double check as well, but we'll see that it's also not going to work, and our answer is definitely A. Here is one more old diploma question, and this is asking us to be able to describe methyl cyclopentane. So the first one with this is probably to identify what it would look like. So methyl cyclopentane means that there are 5 carbons in our ring. So we can rule out carbon or compound 1 and 3 because that's showing 6 carbons in the ring, and we needed 5, and you have a methyl group on the carbon, which we needed as well. So we definitely have number 2 to start. And then because you have a methyl group, you would say it is branched. If you have no group like the methyl, propyl, ethyl, it would be unbranched. The next part with being saturated or unsaturated, it's all dependent on the suffix of the name. And this is ending in ane, which implies there's all single bonds. And we know single bonds are saturated, so this would be 6. And the last part, it's again ending in ane, makes it an alkane. So that would be 8 and not an alkene because there's no double bonds. So I hope you found this helpful. If you did, please subscribe and like the video. And if I can ever help with any other concept, please leave me a comment. Thank you.